Okay, so this is going to be video 3 in our series on naming ionic compounds. Just as a really quick review, of course, you recall that when we're looking at a compound, we have to first recognize whether or not it has more than two elements in the compound, and of course, if it does, then we're going to have to be looking at our polyatomic ion list, figure out which ones are there. Alright, so looking at the examples that I have here, of course, we see the top one that we have two elements here, calcium and phosphorus. So that one is simply named as we've done previously. There's the metal, calcium, and of course phosphorus becomes phosphide in the name. That's fairly straightforward. Alright, in the second one, you'll notice that we have three different elements, calcium, phosphorus, and oxygen. So right off the bat we know, of course, that we're going to have to go to our list and figure out what PO4 is, and you'll note that down there it is, of course, phosphate. So going back to our materials here, we will write it down as calcium phosphate. Alright, now when we're actually doing this, recall that when we were actually dealing with the periodic table, alright, there were times when I said that there were certain metals that would have more than single combining capacity, and in the name, of course, that was signified. In this case, you'll note that it's showing us as being a 3. So when we look at our periodic table here, you'll see, of course, that iron has two different combining capacities, +2 and +3. In the name, of course, it's telling us use the +3. So as you recall from doing this previously, Alright, it's +3. Oxygen, of course, is -2. We do the crisscross, and we end up at Fe2O3, which, of course, is the formula for iron 3 oxide, or rust. Now, that part's actually fairly simple. But what happens when we have to go in the other direction? Alright, what we have to do, of course, is recognize that certain elements on our periodic table are going to have more than single combining capacities, as I've just stated. Alright, and that part is going to have to be taken into account when we actually do the naming. The area in the middle here, from like titanium to copper, and of course from hafnium all the way to gold, majority of these elements have more than single combining capacities, and as a result, we have to be paying attention to that. When we're dealing with elements from alkali metals, earth alkali metals, column 2, and of course the column number 3, scandium and yttrium, they only have single combining capacities of course, +1, +2, or +3. And as a result, we don't actually have to worry about it in the name. As you'll note, I didn't really worry about that at the top up here because, of course, it only has a single combining capacity. That's the only one that can be used. Alright? So when we're dealing with this, what we have to do is pay attention to, does this element, this metal specifically, not the nonmetals, not ever the nonmetals, but the metal, does it have more than a single combining capacity? Well, let's try an example here and I'll show you what I'm talking about. Alright, so this one has only two elements, iron and iodine. Alright, so we're going to see iron iodide. Okay, that part's now becoming fairly simple to figure out. Alright, but when we look at the element, of course, the iron, it has two different combining capacities, +2 and +3. So as such, of course, we're going to have to put which one is being used in the name. Now, when we were doing crisscrossing initially or previously, what happened was, of course, we took the combining capacities, alright, just like right here, alright, and we crisscrossed them to get our formula here. Alright, so what we're going to have to do is reverse our thinking. Alright, so what we're going to do is we're going to take the subscript that's there and put it back up there, and this subscript and put it back up there. So saying that, of course, this 2 is going to go up there, and of course there's a 1 up there, and that says that the iron had a +2. Well, of course, that is one of the combining capacities that the iron has, so we're going to put that into the name as iron 2 iodide. That's fairly straightforward, isn't it? Okay, now let's go one step further. Remember all those rules we had before about, combining capacities, how if they were the same, they canceled out. If they were multiples, we had to divide by the common multiple, etc. Well, that's something we're going to have to deal with here. Right? You're going to become like this chemistry detective, trying to figure out which ones are being used. Alright? So with that in mind, let's have a look at this next example. This one's iron. Alright, Fe. And of course, that's oxygen, so oxide. Now when you look at iron, when you look at this formula, you'll notice that because there's no numbers there, it's assumed there's a 1. Well, when you look at the periodic table, iron doesn't have a combining capacity of +1. It has a +2 or a +3. So what exactly has happened here? All right, now remember that when we're dealing with this, we have to reverse our thinking. If you look at the oxygen, oxygen has a -2 combining capacity, but there's only a 1 down here. So that means, of course, it reduced. All right, so if that one reduced by 2, divided by 2, that means the other one probably divided by 2 as well. And when we look at the periodic table, iron does have a +2 combining capacity, so it's iron 2 oxide. All right, and that makes sense, doesn't it? So like I said, you become this detective. Now, if you're not sure if this combining capacity is the correct combining capacity for your name, what you can do is try and get back your formula, the formula you started with, from the name. And if you can, you've done it correctly. If you can't, then you've made an error in which combining capacity you've actually chosen. All right, well, let's do another one here. You'll notice we've got 3 different elements here: chromium, phosphorus, and oxygen. That's actually, when you look at your list and you look at your periodic table, that's chromium phosphate. And again, of course, when you look at your periodic table, you're going to find, of course, that phosphorus, chromium has 3 different combining capacities: +2, +3, and +6. And then we look at this thing and we find, of course, that, oh, look, there's a radical of phosphate right there, and effectively there's a 1 up there. Well, chromium doesn't have a +1 combining capacity, so again, use your intuition, use your detective skills, and you'll find, of course, that phosphate has a -3 combining capacity, and that means, of course, that it got reduced when it came down here. So it's actually chromium 3 phosphate. All right. Now, this next one, it looks fairly straightforward. It's titanium and oxygen, so it's titanium oxide. All right, and if you look at your periodic table, titanium has 2 different combining capacities, +2 and +4. So we go back over here and we have to figure out, okay, which one's being used? Oh, look, there's a 2. So you could right off the bat go, okay, it's titanium 2 oxide, but will you get the formula TiO2 back from this name? And I can tell you right off, you won't. All right, based on all the rules we've learned so far. So it's not going to be a 2. So again, you'll have to do some detective work. You'll notice that if you check the oxygen, oxygen has a -2 combining capacity, but it didn't come down. There's a 1 there. So it means it must have reduced or something. All right, so what we're going to do is we're going to reverse our thinking. And if this is a 2 here, all right, what would have happened for both of these to be divided by 2 would have been, this would have had to have been a +4. Well, +4 is also one of the combining capacities for titanium, so that's what goes in the name. Try and get the formula back, and you will. So that means that is the correct name. All right. Now, one of the problems that sometimes arises with students is that they will actually misread the formula and think that maybe that what they see is going to be correct. So, for example, in this one, you'll notice we have 3 elements, so it's an element. It is a metal plus a radical. All right, and it's copper nitrate. All right. Now, what you're going to have to do now is check to see which combining capacities copper actually has. You look at your periodic table. Right there is copper. It's got +1 and a +2. So the question is, which one is being used? All right. Now, a common problem that arises is students will look at the subscript in that radical, and they will basically think, oh, that must be the combining capacity of the metal. All right, but unfortunately, obviously that is wrong. All right, that subscript belongs to the radical. It is not part of the metal itself. So as a result, you have to pay close attention to that. All right, in this case, of course, copper has 2 combining capacities, +1 and +2. So what happened here is, since there's no brackets, or there's no number outside the brackets on this one, that means, of course, it was a 1. All right, and that is one of the combining capacities for copper, so it becomes copper 1 nitrate. All right, so there's lots of all these little rules and exceptions that you have to pay attention to. Hopefully you've looked at the other videos and you have a better understanding of how things are supposed to work. All right? Great. Thanks.